Hi everyone, it's Ali from AJ Bros, and in this course we're gonna talk about outlier detection by IQR. As you see in this perspective, we can see that how we can detect the outliers. This video made for people that have a background in statistics, and we're gonna implement the formula in Python. As you see, the number of more than 1/2 5 IQR, less than and more than 1/2 5 IQR are or outlier. And if we had data bigger than or lower than that, this outliers, these are extreme values that we have to manage them, and it's related to our strategy. Okay, let's get started. As you see, I added some module to my program as numpy, pandas, and uh, matplotlib. In the first step, I just want to implement my uh, function that which can detect outliers. I used to writing a function. I gonna call it IQR outlier and get a ARR. That is our actually it's our array that we pass in this function, and this function is the uh, have to detect the outliers by IQR. We should to for first we should to uh, count the number of our array. I call it n and use that. Then Q1 is 25% of 25% of a number of our data, but the value of 25% data, it means that we're gonna uh, take the number of our array, and then we use this formula to get the 25% of our data, and I use this pattern to convert to the int, and then I get it by using that. I copy it for Q3 and finding the 75% of our data here. It's finding these two numbers, and then IQR. I gonna use this formula Q3 minus Q1. Then a lower bound gonna be Q1 minus 1 plus 5 at IQR. As you see that this picture that I show you, it's gonna be our 1 plus 5 uh, at IQR, Q1 minus 1 plus 5, and which numbers that are leader than this number gonna be our outlier. And if we find the numbers more than Q3 plus 1.5 at IQ are gonna be also our outliers. upper bound gonna be Q3 plus 1.5 at IQR. Then we make a loop in our data to recognize that which are are actually outliers. As you see that uh, we made a method and but it's not finished. I used the last things that to recognize that if I is bigger than uh, upper bound or lower than lower bound, then we make an array that we called it out, else means outlier, uh, and I will use that to add our outlier to in this array, and we're gonna return that array to find out that which numbers are outlier. I'm gonna append I here, and it's done. We can actually return our outlier here, that it's our out. Okay, let's use that formula, but for the first step, I prefer to another one, uh, another step of using of this function gonna be the good point for us. Then let's to examine our function, and we're gonna recognize that how it's happened, the outlier, how we're gonna show the outliers in the second part of this video. And thanks for watching till now, and if you like this video, please like it and subscribe on my channel for get better and best. Okay, hello again. uh, I got a little bit tired, and hope that you enjoyed this video. We let's get started to use this function to recognize which outliers we have. I use the np random it with I don't know, for three. It's not matter. I write this line to get same results that in each running of this field. That's why I added this line. You can read it about that in documentation of numpy. I'm gonna use an array I call a number array, which concatenate uh, two different scale of distribution, but normal distribution. I use np dot random dot normal with size of 500, for example, and another same distribution but with a little bit more scale to get outlier in our data. We use this formula It's not exactly a formula, it's a trick that I use. Maybe there is some another faster or shortcut, or I don't know, but I use that to I use that to get the numbers. Okay, I add a I add a size and for example 10% not exactly 10% by 10% outlier with use this numbers scales is means that a scale of this distribution is 1 normal distribution, but the second one is that the scale with 2, that the number that we make here gonna be for outlier, and axis that I should not to forget, axis now here is okay. Let's see the numbers that I get. Okay, but actually I need a histogram to see the distribution of data. Okay, and in the next part I show you the box plot that you can see visually the outliers, and then we use our method to see them in numbers. PLT, that's box plots, AIR. Okay, it's done. These are our outlier. We don't deal with extreme values. We could to customize our function to find extreme values or something like that. But I prefer just show you the outliers in hard way by implementing the method. Okay, let's use our method to find out that which are outlier. I called it out and show you. Okay, I forget to run this line of code, but don't worry. Then we have them. These are our outlier and extreme values together, but we can customize the function to find extreme values and outliers. It's gonna be a good practice for training that. And I hope to enjoy this video and have a good day.